Okay, come, Ethan. For rubbing, you need two insulators of different materials. So, for example, glass and silk, plastic and silk, plastic and cloth. But don't worry too much about the exact materials as long as you know they are insulators. So what happens is one will lose electrons. To the other. So what happens to the one that loses electrons? It becomes lose electrons means it has more positive charges left. So it's positively charged. Try not to make mistake about that. Whereas the other gain electrons. Yes. Okay, so that's the rubbing part, which you need to know. But the only difficult thing is you must have to know what is an insulator, what is a conductor. Are you able to answer 2A?
Yes.
Yeah.
Am I supposed to assume that they're both neutral?
Okay, good point. Well, yes. By right, they should have written that down. Yes. However, I'll give you one additional detail. You are provided with a charged object in addition to the two spheres.
Conductor? Can be both, right?
The charged object doesn't matter actually. It can be conductor or insulator, doesn't matter.
I think you put it near one,
Mm-hmm.
then you put the two things together.
Yeah.
And separate it.
Yes. Yes. Can you try writing that out so that at least I want to see your idea?
The conductor need to be like of a certain charge. Can it be negative?
Here, because the question didn't specify, it can be any, either positive or negative.
You place the conductor on the scale. Contact.
Come, Ethan, the keyword here is induction. So you cannot have contact. Induction is no contact.
You're done.
Done? Okay, come, let me see how you answer that. Okay, good. Good. I think you get the idea already. But of course, just one comment from me, because you can actually have the two spheres together initially. And then you put your charged object close to 1. Therefore, this is positive, and this becomes negative. However, your answer is not wrong. You can put that second sphere to contact the first sphere later on, though you can do them all at the same time. How about the rest? Should be fine. Come, let me see your drawings. Where's your part 1? Okay, up here, negative. Okay, can. Part 2. Yes.
So you can just.
Yeah.
If we happen to have like 5 weeks in that month, the people will not have any lesson.
There will still be a lesson.
Okay, so we paying additional for every fifth one. Okay, understand. Thank you.
Okay, sure. So where's your positive charge? Oh, this one.
Yes.
Then what's happening?
It's. Wait, and yeah, because. The choice is getting food towards something.
So it's asking for a positive charge. So draw the direction of the electric force. Where is your electric force?
Yeah.
This is negative, correct?
Yeah.
This is positive.
Yeah.
Where should we go?
Towards the negative.
Yeah.
Oh.
So let's draw one arrow. Probably because of a different color or using pencil. Okay, pencil. You should not draw in all directions. It's only going towards the negative charge. This one.
Sorry.
This is positive, this is negative. They ask for 2 isolated positive point charges.
Someone's going to draw this thing, but we go next.
Okay, your notes. When you have 2 positive charges, how do the seal lines look like?
Oh.
Oh, don't be careless, huh?
They're supposed to repel each other.
Okay. Now draw it up to see that you get it right.
Something like that.
Ah, okay. Yes, yes. Okay. Yeah, so don't be careless. So this one, no problem. Okay, two examples. We have touched on at least one example. Can you remember which one?
Spark.
When doing what?
Uh,
Ah,
like the example,
the example. What was it about?
you
Ah,
we believe you
yes,
it's not connected to the floor.
the ground. Okay. So that is one, but of course I want you to write in at least in proper English, maybe not so much English, but at least in proper words. Right, refueling, let's say use the example that we did last week, refueling a plane. Can be hazardous. As the fuel becomes, since it's only 2 marks, I won't write that much, charged by friction. An accidental discharge. And cause fire and explosion. Now, the other thing I want you to remember, Ethan, fuel, have you seen it before? You go to the petrol station,
The yellow
yellow, can be yellow, but for aircraft, it's not yellow. It's probably colorless, but it looks like that. It's a liquid. But what you need to remember, the fuel is a insulator. That's why it can become charged by friction. That's the important thing. Okay, the second one is, again, we've done this before, but maybe you can't really remember. It's actually lightning. Orbs can become charged as well. Okay, discharge between Earth and the Earth. It produces lightning. Which can cause fires and electrocution. If possible, remember these examples. I mean, may or may not come out. What about the car?
You did the equation, right?
Okay, then.
Then the car will become charged.
And then
When they alight the car, then they touch the car. Get a shock.
Not that easy. You know why? The first thing, ask yourself, the car, is it insulator or conductor?
Conductor.
Conductor, okay, that's the first thing. So does it get charged by friction? Possible, but not so easy. Second important thing, you may not know this. Do you know how about the tires? Conductor, insulator? Car tire. It seems like insulator because,
Wireless.
yes, that's the thing. So essentially, it still acts as a conductor. So it's very hard to charge the car. The charges will just go down into the ground.
Cool.
Okay, let's go through your MCQs. Some of them are not easy. Number one. Okay. Positive charge means it loses electrons. Can Ethan?
Yeah.
Can try not to get this wrong. Number two. A charged insulator and an uncharged conductor. What will happen? If I have an insulator here, let's say it's negatively charged, and I have a conducting sphere here, what will happen? This will happen, right?
Charge is neutral.
Yeah, but because of induction, yes, attraction will still happen, even though this guy is overall neutral. Yeah, this one you really have to get it right. Okay, attraction can still happen. But of course, if both are very heavy, then obviously they are not going to move on. 3. B for boy. Okay, good. You know why? 4. Yes, good. 5, we have done it just now. Try to remember number 5. 6. D. Okay, good. 7 is a bit tricky. Your answer? C. Okay, good. 8. Okay, good. 9. D for dog.
Yeah.
Okay. 10. Okay. 11. Okay, good. Shouldn't get all this wrong. 12.
B.
B for boy, yeah? Okay, good. 13.
C.
Okay. Look at the rest. Option A, the charge droplets will cover the crowd evenly. Of course, this one is not a fair question now. Because you got to know that the ground is likely to be charged. You know why?
Because the ground is electron.
Okay, but yeah, you're on the right track. Let me ask you. Ground, conductor, insulator.
Little.
Think carefully. Remember, when you have a grounding or earthing, can the electrons move into the ground?
No.
No.
Yeah, you can.
They can, So that makes the ground a conductor, no?
Then the electron can also come.
Yes, because the ground is a conductor.
Oh.
I don't know whether you have to write down that, because they won't ask you that. You're supposed to know that. Oh, okay, come.
Stay with that.
Because look at C. C is definitely right. So in this case, you have all these droplets which are negative, so they move away from one another. So remember, they're falling downwards. And then as they get close to the ground, what do you think will happen? No, before they reach the ground. Do you think there's induction? Yeah, because the ground is a conductor. And because of this induction, then now I have attraction in addition to gravity pulling them down. All right, so I mean, you can think of it that way lah. So basically, the ground will be covered. I mean, how even it is open is subjective, but essentially they will be attracted to the crop. I mean, assuming the crop will be attached to the ground. Okay, can. So just keep this in mind. Keep this in mind. Actually, this chapter is not easy. Luckily, there are no calculations. 14. 15.
C.
Okay, good. 16.
C.
Good. 17. Okay, good. 18.
A.
Oh, good. 19.
B.
Okay, good. At least you get most of the concepts correct. Just don't be careless for some of the easy questions. You want to do some more static electricity? Because I think you may need some more practice. I'll give you some more. Right. Anyway, your school hasn't started on the current electricity yet. Give me a moment. I need to print on my computer. Okay. Come, starting at MCQs, which are the ones you're not sure of? Oh, two, let's see. Stationary negative charge in the direction shown. What is the direction of the electric field? Ethan, do you remember what is the significance of the direction of an electric field? Why are the arrows pointing in a particular way?
The electric force acting on me.
Okay, let's have an example. So let's say I have a positive point charge. The few lines look like this, correct? And they are pointing. Okay, good. But why? Why? Why are they pointing out? There's the definition of the arrows. Go on. Force on more than that. What kind of object? Yes, that's the keyword. On a positive or just a positive charge. the direction of the electric field on a positive charge. So in this case, obviously it will push away, repulsion, due to repulsion.
You will go to the left.
So in this case, this is what is attracted to here. Okay, another way to look at it, maybe easier. Do you expect this to be positive? This one, yes? For this case?
Yes.
Yes, right. All right, so okay, anyway, make it easier. I think it's easier to explain without going to the definition. And I can also, on the other hand, it's also possible that this side is, right? So there's repulsion and attraction. Come, between this guy and this guy, how do the field lines look like? Left to right or right to left?
For negative, you line from right to left.
Okay.
From positive is from left to right.
Mm,
It's right to left also.
yes, because I can actually ignore this guy negative charge now. I just concentrate on this two. How do you draw the field lines in between them?
From positive to left.
Yep. I assume it's a uniform electric field. So you have your answer now.
Direction is the left.
Yep.
But that's not good.
But I hope you're not guessing. So this, I think this is an easier way to determine the direction.
For 7 also.
7.
I mean, a magnet or electric charge.
This one. Magnet has magnetic field. So is that going to affect the electric field? Actually, it will, but what is the most direct answer for this case?
Electric charge.
Yeah, that's all. That's the most direct answer. That's all. How about the structure questions? Did you finish them? Not yet.
Yeah.
Yes,
But I don't know some.
okay, never mind. Which are the ones you don't know?
No. 2D.
2D. Okay. Actually, this one is the same as what we did. What are the potential hazards you mentioned?
Lightning and feeding.
Yeah, so actually you can use this.
You use lightning.
Yeah, I can use lightning.
Oh.
Yeah.
Good. Like getting shocked or something.
From what?
By other people. What's the reason?
But how do you charge? What is being charged in your example? You have to give some context. No? I mean, you're not wrong, but what is being charged? Okay, besides that, any other problem with the structure questions?
3D part. 3D part. 2.
3B up to... this one is not easy because they use the word suggest. It means that the answer is not in your textbook. It's not in your syllabus. You have to figure it out. But before that, do you manage to determine these two answers? Okay, right. Okay, good. Okay, did they ask you to draw? No, no, they didn't. This one is difficult. Come. The answer is due to distance. If you can remember this, even though it's not often asked, the positive charges, they are closer to the, what is this? To the, let me see, to the sphere. So attraction is strong. Of course, in that case, you also have to talk about the negative charges. Okay, so in this case, it's not attraction, it's repulsion. But in your answer, Ethan, I want you to always think about this too. Does attraction apply? Also, ask yourself, does repulsion apply? Those are, always think about this too. Are they present? Okay, besides that, any other?
I think part one. I don't know, I'm quite unsure, but I can answer all the questions.
Oh, okay. Which part one? Question what?
Uh,
Yeah, which one?
uh,
Question 4. Which one? 3, yeah.
so one question.
Oh, question 1.
Yeah.
Part 1. Okay, this one, I want you to highlight. Do you draw anything on your answer? Come, let me see. What did you draw? Okay, not too bad. Yeah, not too bad. Make sure the number are equal, 5 positive and 5 negative. Yeah, okay, can. Correct. But the difficult one is part C.
The positive charges on the right hand side of vector X are being attracted by the negative charges on the left hand side of vector Y. So
But do you notice that the positive charges are closer here?
the conjugated and because it's like pointed,
Yes,
so all the thing will be conjugated in the
yes, that is the word. Because the negative charges are concentrated at the pointed end of Y. Okay, so I want to see the words like concentrated in your answer and the pointed end of Y. Do you know what are lightning rods, Ethan?
Yeah.
How do they look like?
Oh, and then
No, lightning rods are placed on top of buildings.
they're pointed.
Yeah, they are pointed. If you look, go outside and look on the roof of the building, they are always pointed. Because they want the lightning to hit the rod, and then rather than the surrounding roof. That's how they attract the lightning, because this is very concentrated. The charges are concentrated here. Just keep that in mind. Keep that in mind, even though it doesn't come out all the time. Okay, how about the rest? Fine. Mm-hmm. Actually, yes. Remember the direction of the electric force exerted on a positive charge. So make sure you know there's such a force called electric force on okay, I missed out one word, force on a positive charge. Okay, I think the rest should be all right. Come, let's quickly finish, go through the MCQs. Come, number one. Of course, if you got it wrong, let me know. Number three. Good. 4. Close to Y, but the spheres do not touch, is then Earth by touching it with a wire, which is then removed. Y is then moved far away from X. Careless, huh? Okay, that is the a confusing point. The answer is it doesn't matter.
Also, you just neutralize the point.
Yes, it doesn't matter because as long as this guy is positive, this guy will be negative, will be here. Even even if I put the Earth wire here, do you think these charges will move away? No, because this guy is still there, right? So who will move away, or who will be neutralized? This will be neutralized. So if you can remember this, 5. Okay, good. 6. Good. 7. Oh, 7 we have done it just now. 8. Okay, good. 9. This one, maybe you didn't interpret the question correctly. Identical plastic pens. All right, so that means the other pen must be the same charge. So what will happen? Repulsion or attraction? Yeah, so repulsion.
When you when you use friction to induct.
Not induct, don't use that word, because are they in contact? They are, right?
Yeah.
They are in contact, so that's not induction. Induction means no contact. So it's by friction.
They both become like same charge, negative. Because we both insulators to use. Do they both become negative?
Okay, come Ethan, we mentioned this just now. What is our answer? Did I erase it? That part that just now we had this question about rubbing. Rubbing is by friction. So there are two insulators. One become positive, the other must become negative. Because one lose electrons, the other gain electrons. Okay, this one must know. Okay, let's go on. Where were we? Okay, so yep, number 9 is C. Number 10? A. I thought you should be able to get this right. The sphere is put on an insulating mat, so the charges cannot go anywhere. Therefore, the sphere remains neutral overall.
Why is this negatively charged sphere?
Oh, okay. Okay, negatively charged sphere. All right, good. But don't forget, what was the answer you quoted just now? B, A. Okay, good. I missed out that word, but it doesn't matter. You know why? The positive charges will still be attracted here. However, do you notice something? You count the charges. Yeah, more negative than positive. All right, so overall, the sphere is still negative, but just that left side is positive, right side is negative.
Negative charge sphere, they can be positive charges.
Yeah, can. Just that overall, you have more negative. Overall, that is still correct. Yes. I see. You're looking for. Oh, super. Yeah. Oh, yeah, the brother did. I was telling the grandmother didn't tell you. Very last video already, and today's lesson on Zoom. Oh, yeah, then I don't know what happened. He came down, so the teacher wasn't here. He's conducting lesson. So he went back and I keep your granddad the Zoom link. But he can, I don't know whether he went into Zoom or not. So he's with my grandfather. He's all right. Okay. Right. Ethan, all right. Overall, it's still negative. Overall, but it can still have a positive side. I know it's tricky, but you may want to highlight this question. 11? C. Yeah, same thing. So positive will be here. Negative, even though the earthing point is there, it doesn't matter. The negative will still be neutralized, but the positive cannot run anywhere because they're attracted to this guy. Can highlight this question too, because this is a bit tricky. Tell you what, let me quickly look through your answers. All right, hopefully there are no major problems with the structural questions.
By the way,
Mm.
my teacher mentioned the use of a Wims Hurst machine or something.
What machine?
A Wims Hurst machine.
What's that for?
You spin the thing and then there will be charges or something.
Oh, okay.
It's a spark.
Okay.
So I don't know if it's tested or not. So
This is quite unusual though. Do you have any notes on it?
no, it's not even in the textbook.
Yeah, that's the thing. It's not in the textbook. Okay, so what do you have any question on it?
Just don't know how it works.
Don't know how it works. Okay, good, not bad. I want you to write a bit more sure. I think for part C, I thought I asked you to use the word concentrated. You didn't use that. No?
Only down there.
Okay. Okay. Oh, this one. Yeah, try to use whatever info is given. I think I showed it up there. You try to read your question carefully. You notice that they mentioned, look at the first sentence, fuel and hose are insulators. So try to make use of the info that you're given. Sometimes they give false info, but that's not common. So basically, you must mention friction between fuel and hose. I mean, yours is partially right, but sometimes the marker may not be satisfied with it. Causes the fuel, because what else did they tell you, Ethan? You notice they also told you that the fuel is positively charged. So therefore, the fuel lose electrons to the hose. I mean, your answer is not wrong, just that your marker may be quite particular as the question provide all this info. And now the second part, take note, the okay, what did you write again for second part?
We call the spark.
No, the spark is not flammable. It's the fuel that is flammable. All right, the spark or how to charge. Okay, I think okay. I want you to use this particular word. An electrical discharge. The electrical discharge is actually the spark, but try to use some scientific term. It can ignite the flammable fuel. The fuel is the flammable substance, not the spark. Okay, so I mean, you may think these are small details, but sometimes you don't know how the marker is going to look at them. All right, I think Ethan, let me look at I think I put some dots in the first question, right?
Second.
Oh, second question. Yeah, that was the one, the flammable part. I also put some dots here. 1D and 1D. Conductor will become negatively charged. 1B and 1D. Okay, come. 1B and 1D. Your answer is not wrong, but look at 1B especially. It's 2 marks. It's 2 marks. So you may want to write more than just that. So basically, you're right. The positive charges.
You have to write the movement of the charge. Like hence, the electric charges will move towards the left-hand side.
Basically, you mentioned the left side is negatively charged, right? Right. But did you mention that this actually attract the electrons to this left-hand side? while pushing the electrons, while leaving the right-hand side. Yes, you should include that because this is a 2-mark question. You must mention the right-hand side as well. Okay, maybe I can write something like this. In addition to what you've written, the right-hand side of Y has less electrons. So it is positively charged. In addition to what you've written. And look at D as well. 1D. What happens to the charge on conductor Y? How do you answer again? I want you to add electron. Yes, from the Earth. You neutralize the positive charges. Yeah, include that in. Be specific. I think overall you have the concept. Just be a bit careful. Don't make careless mistakes. And try to make your answer as complete as possible. Always think about this, Ethan. When there's attraction, ask yourself, is there repulsion? And vice versa. If there's repulsion, is there attraction also? Okay. Okay, any questions for today? No, then I shall end here.